I'm just giving you an overview of the real-time sensors, real-time aerosol monitors, an advantage for the people who are working with the remote sensing methods, either lidars or any other type of remote sensing methods, ground-based or satellite observations. Whoever is doing kind of remote sensing methods, for them, the real-time aerosol monitors will be an added advantage for to do the characterization of the aerosols. Okay, so I will just give you one example what I did, what our previous team did in Germany with comprehensive way of study of aerosol characterization. Okay, so first of all, from TSI, next slide, please. So it's moving actually. Okay. Yeah. So yes, thank you. So I'm from TSI, working as a manager for India, taking care of aerosol instrumentation division. And at that division, I had three major subdivisions. One is atmospheric aerosol division, and also engine R&D, emissions from the engines, and also mask testing, filter media testing equipment. Okay, so TSI is 60 years old company. We are into continuously designing and developing new equipment for atmospheric aerosol studies, and also for various other applications, health and safety, and fluid mechanics, and there are many other divisions of TSI. As I mentioned, I'm taking care of the atmospheric aerosol divisions. So we had different verticals under this also. So our main customers are from the research and R&D, like research and development, from the academia, who are into real-time aerosol monitoring. So I don't want to give more details on the atmospheric aerosols because you are all experts in this field. But we see, the aerosols have wide range of sources on the ground, from biogenic to anthropogenic and natural source to man-made sources. So it is very complex in nature. Because if you take any aerosol, it can be from a single source with a single chemical composition, or it can be from multiple chemical composition. So people have, earlier Veerabhadran sir also mentioned about chemical and biological aerosol studies, how they are doing with the lidar remote sensing methods. But here what we had is we had real-time monitors. Okay, ground-based monitors, or you can also take it into the balloons, or you can also measure with aircraft systems by taking them with you, where they are very portable equipment. Okay, and if overall the aerosol studies are essential because they are influencing the scattering and absorption of solar radiation, and they are the new particle formations are very much important for CCN studies, cloud condensation nuclear studies, or ice nucleation studies. And also nowadays we are seeing everywhere in India, or especially in northern India, we are facing a lot of air quality issues, and eventually the health effects related to the human exposure of that particulate matter. So all these are very much important. So these aerosols can be thoroughly characterized or studied by three different methods in general, either modeling or observations or experimental, or combination of all. Okay, so I'm into real-time particle matter measurements. So we are having instrumentation for the real-time characterization. So this graph, this picture is from the Louis Pouy, who is one of the famous scientists in this particular field. So majorly the people who are into this field, they measure either particle mass concentrations, or particle number concentrations, or particle size distributions. All. These are the three important parameters. Besides, chemical characterization is also very much important to know the source apportionment or to know the sources of these particular these aerosols. So I generally give this simple chart. So the people who are into mass concentrations, they use for offline methods the Maudy impactors or cascade impactors, or there are instruments called electrical low pressure impactors or TOM, BEM methods, which are FRM methods. And also for number concentrations for nanoparticles, condensation particle counters, or for bigger particles, we have optical particle counters. For nanoparticle sizing, scanning mobility particle sizers are very much important for the nanoparticle sizing, and aerodynamic particle sizers for the larger particles like that. So the issue is we cannot measure with one single equipment for entire range. So we need multiple equipment to cover entire size range of the measurable atmospheric aerosols. Okay. For chemical analysis, many people are using like simple chemical analysis like black carbon or brown carbon. People are using ethylometers, but there are equipment for the offline methods, cascade impactors. You can collect the sample in the cascade impactors and you can do the chemical characterization. Or you can do a real-time chemical characterization with the mass spectrometers. Mass spectrometers are the very good tools for quantitative and qualitative real-time chemical analysis. Okay, so I don't want to get into all those equipment details because I have less time here. However, this is one of the studies what I did during my postdoc in Germany. So this study was, we have started this study in the city of Stuttgart. Stuttgart is one of the biggest cities in Germany, which is highly polluted cities because of industrial, it is highly one of the biggest industrial area. There are companies like Mercedes-Benz, Porsche, and many other key industries are there. And geographically, the city has a unique nature. It is in a nectar valley. It is in a bowl, like surrounded by mountains. Because of that, there is a less wind circulation, and also because of that, the particles are not moving outside. So eventually, that became a highly polluted region. And the government has funded this project, and we have used a big container. Like unfortunately, you can't see that here. So as Jayaraman sir explained about the containers, so we have deployed all the equipment, whatever I mentioned here, 3 different time of flight mass spectrometers, and the scanning mobility particle sizers, aerodynamic particle sizers, and also Maudy impactors and trace gas analyzers, all to put together in a big container, and we deploy to the city center at the downtown of Stuttgart, close to the close to the Bahnhof train station. And we measured in one season, that's a summer season, and we found very good results. Like we initially started only with physical characterization of the aerosols from the ground-based equipment, and then after I left the institute, our group has started with the LiDAR, Raman LiDAR. They found really very good results correlating with the ground-based instrumentation with the remote sensing methods. And this paper just recently published for one of the conferences, and the full results are yet to come. And what I can say is these kind of the comprehensive study. So if you look at the study, so they studied until several, maybe 1 or 2 kilometers at height of the ground. So they have complete systematic study with the remote sensing, and also they have a study of ground aerosols, what is going on the ground. So complete physical and chemical characterization of the aerosols from 10 nanometer up to few microns, up to 20 microns. So which will be a comprehensive study, which gives a good information about aerosols. Okay, what is happening in that particular region. So this, in a lighter note, I can tell you that the ground-based equipment will be an added advantage for